So this is lecture 5.4 on multiplying polynomials. And I just want to remind you that we're going to be using the commutativity of multiplication constantly, and I'm not going to say anything about it. I'm just going to be using it. So if A, B, and C are real numbers, then all of the following are equal. A times B times C, A times C times B, B times A times C, B times C times A, C times A times B, C times B times A. There's nothing to memorize here. All we're doing is rearranging the order of the terms, and that's what the commutative property of multiplication allows us to do. So let's look at the first example. So 2x to the third times 5x to the sixth. The easy way to do it is just to move. So this is a polynomial term. So just to remind you, this is one polynomial term. This is a degree 3 term. 2 is the coefficient. 5x to the sixth. This is a polynomial term. X to the sixth is the variable. It's to the degree 6, and 5 is the coefficient. So what I say do is collect like terms. So collect the coefficients and then the powers of the x term. 2 times 5 is 10, and then we just use our exponentiation rules to add the exponents. 3 plus 6 is 9. So 2x to the third times 5x to the sixth is equal to 10x to the ninth. Here, again, it looks more complicated, but really we're just doing more of the same. That is being multiplied, so this is a monomial by another monomial. So again, you can do this any way you want, but I'm going to take the coefficients, which is, remember, minus x is the same as minus 1 times x. So that's minus 1. I don't like the way I wrote that 1. That's minus 1 times 7. So those are all the coefficient terms. Then I'm going to put all of the y terms together. And then all of the z terms together. And you don't have to go in alphabetical order. And you can see I haven't. That's supposed to be z to the fifth. You haven't. I have not gone in alphabetical order because my lone x term is out there at the very end. And this gives us minus 7 y to the 4 plus 11 is to the 15th. Z to the 4 plus 5 is z to the 9th times x. That's a perfectly acceptable way to do it. If MyMathLab for some reason wants you to put them in alphabetical order, you would just rearrange using the commutative property. Minus 7x y to the 15th and z to the 9th. And this is perfectly fine. And in a way, having them in alphabetical order is preferable because when we are doing a lot of this and we're collecting like terms, it's easier to go in alphabetical order. But because of the property of commutativity, both are okay. And alphabetical order is something that humans just came up with. And I would never count you off for either of these two, or any rearrangement of the term. The only real standard thing we have is the coefficient needs to be at the very front. And then it's preferable, I guess, to have them in alphabetical order. So we're moving up a step. And here we're just going to use distribution. So I'm hoping a lot of this is going to be review for you. So I have 2x times 5x minus 4. So distribution says take my first term, the entire thing, and multiply it by first the first term and then the second term together with its sign. So that's going to be 2x. I'm going to break this down for you, the first one or two I do, minus 2x times 4. So this is the same as 2 times 5, which is 10. X times x is x squared. This is the same as 2 times 4, or minus 2 times 4 if you want, because the minus is attached to the minus 2. Otherwise, just leave the sign as it is. 2 times 4 is 8 times x. So 10x squared minus 8x. And we're just going to play some more around with that theme. Minus 3x squared times 4x squared minus 6x plus 1. And now we're going to do these more or less in our head as we go along. So I'm taking the entire first term and I'm multiplying it by the next one. So minus 3 times 4 is minus 12. X squared times x squared, I add the exponents to get minus 12x to the fourth. Now I'm going to multiply it by the minus 6x term. So minus 3 times minus 6 is plus 18. X squared times x is x cubed. And then finally, by the last term, minus 3x squared times 1 is minus 3x squared. And if you note right here that each of these terms, this is a degree 4 term, a degree 3 term, and a degree 2 term, and they're written in descending order. And that is the preferred order. It doesn't make it incorrect if you do it a different way, but it's kind of like a housekeeping chore. If you're going to be doing more with this polynomial later on down the line, having them in a specific order, in descending order, the order is by degree of each term. So that said, let's go ahead and do number C. Minus xy times, in parentheses again, it's just distribution here, 7x squared y plus 3xy minus 11. So again, distribution is what's ruling. We're going to take all of the outside term and I'm going to multiply it by each of these three terms. So minus 1, remember this is minus 1 times 7 is minus 7. X times x squared is x cubed. Y times y is y cubed. Y squared. Minus 1 times 3 is minus 3. X times x is x squared. Y times y is y squared. Minus 1 times minus 11 is plus 11. xy. This is the same as minus 11 times minus xy, so it's plus 11xy. And this is, notice again, a good review. This is a degree 5 term because we add up the powers on each variable. So this is a degree 5, this is a degree 4, and this is a degree 2. We're missing our degree 3 term, but that's okay. It doesn't necessarily have to be in there. The point is, I write them in descending order. So here are, we're already here. So we're getting ready to multiply a binomial by a binomial and a binomial by a trinomial. And many of you in school were taught a way to do this, and I want to emphasize that you can still use that way, but I'm going to teach you two ways. So with this, most of this should be, this is 3a. So x plus 3, that's a polynomial with two terms, that's called a binomial. And 52x plus 5 is another polynomial with two terms. So this is the multiplication of a binomial times a binomial. And you may have been taught to do that using a method called FOIL. It's really popular. I'm not a fan. And the reason I'm not a fan is because it only works for when you multiply two binomials. But on the other hand, we multiply two binomials an awful lot. So even though it only works for the multiplication of two binomials, it's used enough that we can use. So so here is my first term in my first binomial, and here is the first term in my second. So that's my first term multiplication. Get a little bit more room here. My outer multiplication is, so this is my first, so my outer ones are my x and my 2. I need to get a little bit more room. So that's my outer. Then my inner is going to be my 3 and my 52. So that's my inner. And my last are going to be my 3 and my 2. So first is the first terms in each binomial. The outer terms is when they're put together, they're the extreme terms. The inner terms are the two close together. And then the last term are the second term in the first binomial and the second term in the second. So doing that, multiplying first terms, we go x times 52x. So that gives us 52x squared. Then we go our outer terms, so that's x times 2. So that's plus 2x. We always put the coefficient in the first. Then we go the inner terms. 3 times 52x is 156x. Then we do our outer, which is 3 times 2, which is 6. Now we've got it all down there, but we have to collect like terms. And our only like terms are these middle terms right here. So the final end answer is 52x squared plus 158x plus 50. Did I write that down wrong? Oh, well, again, I miscopied. That should be 5, but let's just go with 2. It does not matter. Plus 6. So 3 times 52, 6, 156, 6, 2. Good. So let's do this another way. So I replaced the 5 with the 2, so I'll replace the 5 with the 2 again. So I'm going to do 3a a new way. Both ways are good to know. But we're going to do, again, x plus 3, 52 plus 52x plus 2. So So yes, I changed the problem just a little bit. If you want to see the answer to the actual one, just look in the book. So here's what I'm going to do. I'm going to break this up into what's called a linear combination. So all I'm going to do is I'm going to take my x and I'm going to multiply my x by, it's literally distribution, but x is getting distributed over all of my second term. And then I'm going to take my second term in my binomial and again multiply it by everything under the second parentheses. So now we've reduced the problem to something that we've done earlier. So x times 52x is 52x squared. X times 2 is plus 2x. 3 times 52x is 156x. And then 3 times 2 is plus 6. And you notice we get the exact same ordering as we did when we used the FOIL method. The only thing about this is I think it breaks it up to one more step. You don't have to remember what's first, what's outer, what's inner, what's last. We still have to simplify. And this method works for every type of multiplication of polynomials. In particular, 3b. FOIL only works when there are two binomials. Well, this is a binomial and this is a trinomial. So we will have to use the method that I just used for this one, because there is no FOIL method for it that's easy to do. You could do it and break it down, but let's just do it this way, and then you all can choose to do whatever method. All of this really should be review. So again, we take 2x, the first term, and we multiply it by all of the next factor enclosed in parentheses. Then I take the next term together with its sign, do the same thing, multiply the whole thing by 5x squared minus 6x plus 7. Now it's just a matter of easy distribution. Then we'll have to do simplification by collecting like terms. 2x times 5x squared, well, 2 times 5 is 10. X times x squared is x cubed. So 2x times minus 6x, so 2 times minus 6 is minus 12. X times x is x squared. Then 2x times 7 is plus 14x. Minus 3 times 5x squared is minus 3 times 5, which is minus 15x squared. Minus 3 times minus 6x is minus 3 times minus 6 is plus 18 times x. And minus 3 times plus 7 is minus 21. So now what we want to do is we want to collect like terms. And I'm just going to do it all at once. So 10x cubed. There are no x cubed terms other than that one. Then I'm going to write down minus 12x squared. And there's another x squared term. Then my degree 1 terms. So I'm just going down in descending order of degree. And then my degree 0 terms are my constant terms. So here are my groupings. These two are like terms, and these two are like terms. So the answer turns out to be 10x cubed. Minus 12 minus 15 is minus 27 x squared. 14 plus 18, 2 is plus 32x, and then I have minus 21. So 10x cubed minus 27x squared plus 32x minus 21. So just more examples. This is really getting at the heart, finally, of intermediate algebra. But technically, all of this should be something vaguely familiar to you, if not really familiar to you. So I'm going to go ahead and do this the same way, just do them all the same. So that's x times 2x plus 3. If you know how to FOIL, you can go ahead and FOIL. So this is equal to 2x squared, because literally I'm just doing the distribution here. X times 3 is 3x, plus 5 times 2x is plus 10x, and plus 5 times 3 is 15. I still have to collect like terms, and those are just my two middle terms, and I get my answer. And for the last one, 4b, 3x minus 1 times 5x squared minus 6x plus 2. So this is equal to 3x times 5x squared minus 6x plus 2. Take the second term together with its sign and multiply it by that same second grouping. And then at the end we have to, now you just use distribution. So again, I'm just using distribution with each term. Distribution's really important in math. So 3x times 5x squared is 3 times 5 is 15. X times x squared is x cubed. 3x times minus x is minus 6x is 3 times minus 6 is minus 18. X times x is x squared. 3x times 2, well 3 times 2 is plus 6, and I have my x there. Now minus 1 times 5x squared is minus 5x squared. Minus 1 times minus 6x is plus 6x. Minus 1 times 2 is minus 2. So let's go ahead and collect like terms. So I have my degree 3 term down. Let's do my degree 2 terms. I'm just writing a line through them, so I'll make sure that I get them all copied down. My degree 1 terms, and then my degree 0 terms. And our final answer is, well here, these we have to add together. These are like terms, and these are like terms. So the final is 15x cubed. Minus 18 minus 5 is minus 23 x squared. 6x plus 6x is plus 12x minus 2. Okay, not so bad, hopefully. So multiply vertically. We're going to multiply vertically. So what we're going to do is we're going to put, and you don't have to do this. This really helps some people. Plus, my cat wants outside, but she's not going outside. And then we're going to do 4 x squared plus 0x, plus 7. So I had to put a 0x so that just like 152 times 107, I have to put a 0 times the 10th power there. And then we just literally multiply through. So 7 times 8 is 56. But we don't do the carry. 7 times 2x is 14x. 7 times x squared is 7x squared. 0 times 8 is 0. 0x times 2x is 0x squared. 0x times x squared is 0x cubed. So that's just 0. Then finally, 4x squared times 8 is 32x squared. So I put it underneath my 32x squared column. 4x squared times 2x is 8x cubed. And 4x squared times x squared is 4x to the 4th. And then we just add down. These are all pluses here. So I get 56, 14x, 7x squared plus 32x squared is 39x squared. 0x cubed plus 8x cubed, all I'm really doing is just adding the coefficients. And then 4x to the 4th. So I don't know if you like that method of multiplying vertically or not. But there it is, and if you want to explore more of it, it's in the book right before Objective 2. But that's all I'm going to do with it. I actually don't find it much easier. So multiplying binomials, we just have been doing binomials. It's the FOIL method. I've already taught you the FOIL method, and we're just going to do some more multiplying by binomials. It's kind of weird that they already have us multiply binomials and then they introduce the FOIL method later on, but we will actually do these using the FOIL method because I think that's what they want us to do. It is helpful to know both. So we have x plus 1 times x plus 2. It allows you to do a lot of things in your head. So remember, first, outer, inner, last. So I'm going to go ahead and write the answer down here. Our first terms is x times x, so that's x squared. My outer terms is x times 2, which is 2x. My inner terms is 1 times x. And then my last terms are 1 times 2. So that gives me x squared plus 3x plus 2. And if you're doing this on an exam, even if you can do it in your head, I would expect to see step 2 and step 3. Because it's too easy for you, it's too easy just to go to a symbolic engine and just write down the answer. I've already mentioned, for now, since we're doing this online, I don't care if you can do it in your head. If I could see the contents of your head, I would be fine. But I cannot grade the contents of your head. If you want me to grade it, it has to be on paper where I can see it. So again, this is just an exercise in FOIL. Again, first, outer, inner, last. So 2x times x is 2x squared. Outer is 2x times 5. So that's 10x. Inner is minus 4x. And then last is minus 4 times 5. We have to collect these two terms. And two more examples. So FOIL is really big in math education. Everyone seems to know about FOIL. Like I said, I'm kind of quasi-indifferent about it. The only reason I'm a supporter of FOIL is because there are so many instances in math when we literally are multiplying binomials. Because it only works for binomials. But there's plenty of times when it works. So 2x times 3x is 6x squared. So that's first, and my outer is 2x times minus 4. So that's minus 8x. Inner is minus 7 times 3x is minus 21x. And last, minus 7 times minus 4 is plus 28. So we always have to combine the middle terms. The terms actually, the second step, even when you do it the other way, the terms are in the exact same order. So minus 8x minus 21x is minus 29x. And then we have plus 28. You should definitely be pausing the video and working these out. Math is not something that you can do passively. It's not like something you can read up on and it sticks. You have to get out a pencil and piece of paper and work on things. Math is not something you can cram. As many of you may have already found out, one way or the other. So again, we're going to use FOIL. 3x squared times 5x squared. Well, 3 times 5 is 15. X squared times x squared is x to the 4th. So that's my first. My outer is 3x squared times minus 2y. So 3 times minus 2 is minus 6. X squared y. 4 times, y times 5x squared. Those are my inner terms. That's 5 times x squared y. And then my last terms, that's minus 2y squared. And we do have two like terms. They need to be combined. So minus 6x squared y plus 5x squared y is minus x squared y. And then I have minus 2y squared. So squaring binomials, these are called special products. So here's the deal. These are three formulas. They're worth memorizing. So let's look at them. So we have a binomial a plus b squared. So remember, first, that a plus b squared is just shorthand for a plus b times a plus b. So you would not necessarily have to memorize these formulas, but again, these are really common. So it's helpful to do it. Especially number 3. Number 3 is a necessity. So let's look. A plus b squared is I take the first term and I square it, whatever it happens to be. Then I square the last term. And then the middle term is I multiply the two terms together, a times b, and then I multiply that by 2. So over here I do the same thing. My first term is a squared. My last term is b squared. Then my middle term is a times minus b, which is minus ab, and I multiply it by 2 to get minus 2ab. A squared minus b squared is simply a plus b times a minus b. So they're ab, with one of the terms being added and the other being subtracted. This one is really important. This one's harder to get on your own. These, you could figure out either one of them by writing a plus b squared is a plus b times a plus b, but these are really time-saving formulas. Note how 3 is different from 1 and 2, and it's important that you memorize at least 3 for now. I suggest memorizing all of them, although the hope is that just by doing your homework and doing a lot of examples, you won't have to have them memorized. So notice the square here. So what do is I take the first term, x, whatever it is, and I square it. And I take the last term and I square it. So 5 squared is 25. Then I multiply 5 times x to get 5x, and then multiply that by 2. So 5x times 2 is plus 10x. See how easy that one was? B, x minus 9 squared. So again, x squared is x squared. Minus 9 times minus 9 is plus 81. Minus 9 times x is minus 9x, and then I multiply it by 2 to get minus 18x. And let's do C. Notice how I'm literally doing all of this in my head, and it's okay that you do so on the exam when it has to do with special products only. So my first term here is 3x. So I'm going to do this in 2 steps. So it's going to be 3x squared. My last term is 2z. So I'm going to do plus 2z squared. In my middle term, so my 2 terms in parentheses multiplied together is 2 times 3 is 6. X times z is xz. So that's 6xz, and then I have to multiply it by 2. So that's plus 12xz. So remember this rule, ab to the nth is equal to a to the nth, b to the nth. So this is equal to 3 squared, which is 9. And that's 2z. 2 squared is 4z squared. So here is my warning. This causes problems. The most common mistake is you will write down 3x squared and 2z to 2z squared. But that's not using this rule, and that's the reason I put these terms. It's the entirety of the first term that is squared. It's in the entirety of the second term that is squared. And here this is called the difference of squares factorization, or formula. So I want to remind you of that one. This is one you must absolutely remember, is a minus b times a plus b is equal to a squared minus b squared. Now notice it does not matter which order I put these in, because this is one factor times another factor. So the following is a completely equivalent formula. A plus b times a minus b is equal to a squared minus b squared. Notice I'm not allowed to switch the order of these two because a minus b in general is not the same thing as b minus a. Just check it out. 5 minus 3 is equal to 2, and that's not equal to 3 minus 5, which is equal to minus 2. So I get a negative sign error. So we don't, these stay in the same order, but the factors here, because this is multiplication, which is the main operation, I can move them around. It's commutative property. I started out this entire lecture by talking about that. I can, subtraction does not have that same property. So let's do it. So by the formula, x minus 3 times x plus 3, that's equal to x squared minus 9. Where do I get the 9? X times x is x squared. Minus 3 times 3 is minus 9. Let's do 9b. X squared plus 2y times x squared minus 2y. Now, of course, you could just go ahead and FOIL these out, but isn't it so much easier just to say x squared times x squared is x to the 4th. 2y minus 2y is minus 4y squared. And 9c, especially when we have fractions, 3m squared minus 1/2 times 3m squared plus 1/2. You just have to know how to recognize them. They're exactly the same. The two terms are almost exactly the same, but they differ by the minus sign. So if you look at these, the only difference between these two terms is the minus and the plus. Well, this is equal to 3 times 3, which is 9. M squared times m squared, which is m to the 4th. Minus 1/2 minus 1 times plus 1/2 is minus 1/4. There couldn't be anything more easy than that. So let's multiply this one. Again, look for patterns. So we have brackets, and then we have 5x minus 2y minus 1 times the very same thing, 5x minus 2y plus 1. So if you need to see this, let 5x minus 2y be equal to some letter, b. And then you could literally write this as b minus 1 times b plus 1, and immediately say that's the same thing as b squared minus 1. But of course you're going to have to replace b with 5x minus 2y squared minus 1. And that's exactly what we're going to do. I'm going to notice that these are my first terms. And then my second terms differ only by a minus sign. So it's my first term squared minus 1 times plus 1 is minus 1. But I'm not done yet. Now I get to use another special product, the special product of squaring. This is equal to 5x squared minus 2y squared. Don't forget to bring down the minus 1. And then 5x minus 2y. So 5x times minus 2y is minus 10xy. Then multiply it by 2. Don't forget to multiply it by 2. So that's minus 20xy. So 5x squared is 25x squared minus 20xy minus 2y squared. Minus 2 times minus 2 is plus 4. Y times y is y squared minus 1. And what else do we have for this particular lecture? A little bit late in getting it out. Okay, we have to do just, I guess, 1 or 2 more pages. So here is another good example. Now, number 11 is very much like an example you would see on an exam, because I'm able to add 2 skills on 1. So let's do number 11. So we have x minus 3 times x plus 3 times x squared minus 9. Now I'm noticing a pattern that I can use the difference of squares on the first 3. So I'm going to multiply the first 2 factors. I said that wrong. I'm noticing the first 2 factors are a difference of squares. X minus 3, x plus 3, they only differ in the sign of the 3. So I'm going to use the difference of squares. So that's x times x is x squared. Minus 3 times minus 3 is minus 9. And then I have x squared minus 9. Wow, if only I had a plus there, but I don't. But I remember that this is just shorthand for x squared minus 9 times itself. It's another way of x squared minus 9 squared. So I can use the squaring formula. So that's x squared squared, x to the 4th, minus 9 squared is plus 81. And then minus 9x squared times 2 is minus 18x squared. See how easy that one was, done completely in your head. So now we're just going to evaluate polynomials where the input is an expression. So I'll just go ahead and write this. I literally think it's my last page, so I can't scroll up any. Yep, it is my last page, so I cannot scroll up. So I'm going to write it down here. We're going to let f of x, that's a function notation, and remember every polynomial can be made into a function. You need an equal sign there. X squared plus 5x minus 2. So we are asked to find f of a plus 1. So this is my input value. So what I do is I just replace my x with my input value. I'm just replacing the x, and the x is squared. Replace my x with the input value. So now I can use my squaring formula. This is a squared plus 2a plus 1. Here I just use distribution. This is plus 5a plus 5 minus 2. So what's the very last thing I have to do? I have to collect like terms. So there's my highest degree term, my x squared term. Then I'm going to put next to each other my degree 1 terms. And then I'm going to collect all of my constant terms. And now simplify. I have to simplify my degree 1 terms and my constant terms. So the final answer is a squared plus 7a. 1 plus 5 is 6 minus 2 is plus 4. And we're done. Yeah, that's it. So that's it for 5.4. Tomorrow I'm going to upload 5.5. It's really important, so you'll need to get on that one as soon as you can.